Hi, I'm Xavier, and today I'll be showcasing my static analysis. The first step of analyzing a malicious executable is to scan the file using an antivirus scanner. This will be done using VirusTotal, and as you can see here, it is flagged as malicious and is categorized as a Trojan or a keylogger. Some details about it are the MD5 hash, the history, and the common names, some relations, contactor IP addresses, execution parents, and the behavior of the malware. Persistence, privilege, escalation, defense, evasion, discovery, some network communications with these IP addresses, some file system actions, registry actions, process actions, and highlighter actions. Moving on, we'll now use PEID to check whether the malware is packed or not. And as you can see here, it's packed by a common packer called UPX. Malware authors often pack their malware for obfuscation, and unpacking the malware to is necessary to understand the true nature of this malware. This will be done using a plugin called Unpacker for UPX. And as you can see here, the unpacked version is unpacked. Now we will fingerprint the malware using WinMD5. And as you can see here, the packed version has the same MD5 hash as the one we saw on VirusTotal. However, the unpacked malware has a different hash and also a different file size. Now we'll look at administrative information using PEView. As you can see here, the unpacked version has a file creation time under image file header as 2031, which is suspicious because we're in 2024. This is this cannot happen, and we can determine that it's made in a modified environment. As such, we can try the packed version, which shows us a 2003-05-14 file creation time, which is more believable. So we can determine this as the actual time. Now we'll look at dependency walker. And as you can see here, there's 4 main DLLs. Firstly, the advanced API 32. It shows us some host-based indicators that malware wants to modify registry keys with regdelete value, regopen key, and regset value. The secure32 DIL files also show some imported functions that indicate that it's trying to find out the user login details, like get username XW, get username XA, or take control of the machine through impersonation with LSA logon user. This falls in line with the VirusTotal as categorizes this as keylogger. Kernel32 imports functions like copy file, create process, and a lot of get functions, as well as terminate process and write file. This indicates to me as gathering of information of the computer system. User32.dll has nothing much, and the WS232.dll shows imported functions that indicate the malware is trying to establish connections with IP address for maybe data exfiltration. Moving on, we'll now look at the strings extracted from the malware. And as you can see here, there's a lot of plain text data that's extracted from this malicious file. But however, we'll focus on some suspicious looking strings. As you can see here, there's a suspicious string called user32.dll with the user32 not being capitalized. There's a legitimate file that is capitalized, which means that it could be disguising itself as the other legitimate file. There's also a network-based indicator, an IP address over here, which could be the IP address that the malware tries to establish network connections with. There's also syslog.exe, which could be a created file by the malware when run, as well as a registry key path for running softwares, and could be an indicator of malware persistence, as it starts the malware every time the system powers on. In summary, the file seems to be a keylogger or system logger. Due to VirusTotal analysis and imported functions in the secure32 DLL file, it also has malware persistence using auto-start registry key and evades defenses through obfuscation. Moving on, now I'll talk about my advanced static analysis. As seen over here, this is IDA Pro. The main displays of IDA Pro are seen, this assembly window where it shows the machine language code of the executable file for analysis. It can be switched between graph view and text view. The functions window shows the different functions that are in the executable, and the import window shows the imported functions, and the strings window which shows the strings extracted from the malicious executable. There's also a plugin called WinGraph, which shows control flow relationship between code blocks and function structure, helping analysts to understand the structure of this example code. Firstly, to start off the analysis, we will look at the main function of this. And as you can see here, there's a get module file name A that is used to obtain the executable file name, and a copy file A function that is called to maybe duplicate the executable to a new file. This could ensure persistence as duplication of the malware may happen. The code also shows a registry being opened using regopen key XA and setting a value called Microsoft syslog using regsetValue XA. The registry actions could be used to establish persistence. Moving on, further down the code block, we can see in text view, As you can see here, this command appears to handle a specific command line condition to delete a registry value and terminate the executable. The presence of /kill that leads to a deletion of registry value and termination of process could be part of a self-destruct mechanism or an attempt to remove traces on the malware using reg delete value A. Going back to graph view, moving down, we can see another function over here. And as you can see, this loop appears to be a mechanism for the program to repeatedly attempt to connect to a remote server, introducing a delay upon failure. The code initializes WinSock, creates a socket, and repeatedly attempts to connect to a remote server within a loop. If the connection fails, the program introduces a sleep delay of 7,530 milliseconds before retrying the connection. Some of the potential goals of this are attempting to establish connection to a remote server for receiving commands or attempting to send sensitive information from the affected system to a remote server, which is data exfiltration. The sleep delay also suggests to me a form of defense evasion to avoid detection by waiting a while before trying to establish connection again. Moving on, now there's a final code block over here, which involves setting up and executing a new process using the imported function create process A. This could be intended to execute commands to allow the attacker to have free rein to perform malicious actions on an infected system. The use of cmd.exe also indicates an interaction with the command line interface. Launching a new process, especially the command prompt, could be part of a strategy to maintain persistence or evading detection. In summary, this malware first starts off performing file and registry manipulation. It also attempts to introduce a network connection, establishing a loop to ensure persistent communication, and a delay upon failure in between to evade defenses. It then launches a command prompt process with specific socket handle configurations, and as such, I can determine that the goal of this malware is to establish communication with a remote server, probably and most likely for command and control purposes, and to then execute commands on the infected system. Thank you for listening.